Good morning, everyone. Today we'll be doing January 2023, number 7. Number 7 is usually, not usually, majority of the time, it is these sequence questions, right, that you have to use you have to apply to do these questions, right? So this first question says the grid below shows the first three figures in a sequence. Each figure is made using a set of small squares of unit length, and they are both colored, which is shaded, and white, which is unshaded, right? So if we look at this, figure 1 has 1, 2, 3, 1, 2, 3. So it's a square which is 3 by 3. Figure 2 is, we can see the black lines. It's 1, 2, 3, 4 by 1, 2, 3, 4. And then figure 3 would be 5 by 5. So obviously, figure 4 will be, it's increasing by 1. So it will be 6 by 6. So let's count 6. 1, 2, 3, 4, 5, 6. Right? And then we're going to go up again. 1, 2, 3, 4, 5, 6. Is that 6 and 6? Yeah. And then we're going to go across. 1, 2, 3, 4, 5, 6. And then we're going to go down. 1, 2, 3, 4, 5, 6. Right? So this is how the big square is going to look. And then we're going to do the shaded part. Oh, this is going to be something. Right? So the shaded part, I guess I could use my, I don't want to use the highlighter. It would be, we saw that it's going up, we saw it's increasing by 1 in the shaded part. 1, 2, 3, 4. This one was 1, 2, 3, 4, 5. So obviously this is going to be 1, 2, 3, 4, 5, 6. So we're going to have, oh boy, this is 1. Oh no, you know what? I'm going to use what you call it, the highlighter, just to do a brief review because this is going to take a while. All right, 1, 2, 3, 4, 5, 6, and then we have 6 across, which is this entire thing here. And this would be, I mean, guys, obviously, because I'm using the whiteboard, that's why it's looking like that. But you guys would shade it properly. And this would be basically how the figure 4 is going to look. All right? So now let's go on to the second part of the question, which is, the second part of the question is the table. This is usually the table that you have to answer. Now, this question, I can make this a little bit bigger. All right. The figure, the number of colored squares C and the total number of squares T and the perimeter of the figure P shows a pattern. Study the pattern in the table below and answer the questions that follows. Right? Now, the formula for this that we have to learn is, so as I said, the first thing we have to check is what type of sequence they are, if they are increasing by a specific value. So if we look at the number of colored squares C, we see that from your first figure to your second figure to your third figure, 5 to 7 you have to add 2, and then 7 plus 2 would be 9. So we can see that this is increasing by a constant value. And if we look at the perimeter, it is also 12 to 16, your difference is 4. So 12 plus 4 would give you 16. 16 plus 4 would give you 20. So we know that this is a constant. We have to add, we'll be adding 2 here, then you add 2 to get the next value, right? And then you add 2 to get this value. And if they were to ask you the fourth figure, you would have to add 2 to 9 to get the fourth value, all right? Same thing here. You had to add 4 to get 16, and add 4 again to get 20, right? So we can see that it's an arithmetic sequence, right? Now, this is the formula, arithmetic sequence. The formula is an. The n term would be whatever the figure number is, right? Is equals to a1. So n is the term yes, is the term in question, right? Then a1 would be your first value in the sequence, and then d, n is, well, I said the term in question already. D is your common difference, is the difference, right? D-I-F-F-E-R-E-N-C-E, right? So if they ask you for figure 11, right? That means that n would be equal to 11. Our first value for the number of squares would be 5, and your difference is 2. So for number 1, I always usually tell you find this first, guys. This right here, the n term, but we'll do number 1, then 2, and then 3. So for number 1, right, we know that the n term, which is the term that you're trying to figure out, is n is equal to 11. Your common difference, or your first value, sorry, a1 would be your first value, which would be 5. And then your difference, we already figured out the difference between 5 and 7 is 2. So your common difference is 2. So we put it in this formula. N is equals to 11. So A11 is equal to A1, which is 5, right? Plus, open bracket, n is 11, minus 1, close bracket, and your difference is 2. So we're going to do this. So A11 would have been 5 plus 11 minus 1 is 10 by 2, which is 20. So it's 5 plus 20, which is equals to 25. So for my number of colored squares for my 11th term, this would be 25. Yeah? And then if we look at this, guys, we can clearly see, we're going to talk about the total number of squares, right? We can see that, okay, this first term, so what we're going to do for this, if you have something like this, you're going to look at each term. 1, 2, 3. We can see that's your figure number, right? So let me just switch to the side here for my total number of squares, right? We're going to look at the pattern, right? We have 1 plus 2 all squared is equal to 9, right? Okay. And then we have 2 plus 2 squared is equals to 16. And then we have 3 plus 2 squared, is equal to 25. Right? So what we can see is if we look at this first values, 1, 2, 3, those are actually your figure numbers. For your total number of squares, your first term in that formula that they gave you is your figure number, right? And then we can see the second term is actually constant, which is 2. Right? And then, well, these last values here is when you add them up. So if I said, well, I want for my 11th term, right? So they said my first term is my figure number. So we know for this, my figure number would be open bracket 11. My constant is 2, close bracket squared, and 11 plus 2 is 13. Yeah? And then 13 squared is 169, I believe. And that would be my answer for this. Now, when they say something like this, right, they're kind of helping you out. If you look at this, we know that our first term, we're going to look at part 2. We know that the first term in your total number of squares is actually a figure number. So we know that part 2, this would actually be your 23rd figure number, right? And then we can use a formula for parameter of figure P to actually find out the value here. So we will know, again, parameter P is what? Arithmetic sequence, right? And then we're going to use it. We know that for figure 23, my n term is actually 23. A1 in this would be my first term in that sequence, or the parameter of a figure. So A1 is actually equal to, let me just fix that back. A1 is 12, right? And then A1 is 12. And then your difference, which is the difference between your first and second term, is actually 4. So this is increasing by 4. So we apply it to the same formula that we're supposed to know. AN is equals to A1 plus open bracket n minus 1 by D. We know your n term is 23, so let me just shift this around. I probably have place here, but I'm going to just, So if my figure is 23, that means it's A23 is equal to my first term, which is 12, right? Plus open bracket, it's n minus 1, so it's 23 minus 1 by my common difference of 4. So this is equals to 12 plus 23 minus 1 is actually 22 by 4. We know 4 twos are 80, 22 by 4 is 88, so it's 12 plus 88, which is equal to 8 plus 2 is 10, 1 plus 8 is 9, and then the next one outside is 100. So we know that your parameter of figure P for your 23rd term is 100. Right, and now let us find the formula for when your figure number is n. So for this last part here, how many white squares in? Okay. For your last one here, right, this would be, we're going to do part 3, right, is where they told you to find your formula, or not your formula, your figure number is actually n. So for my, what is this, the heading for this? For my number of colored squares, it will actually be, figure number is n, A1 is equal to, let me make sure I don't make any mistakes, is equal to 5, right? A1 is 5, and the difference is 2, right? So you're going to put it in the formula that we know AN is equal to A1 plus open bracket n minus 1 by D. So everything you see in here, you just put it in the formula. So when we know the figure number is n, that's actually AN is equals to A1 is 5 plus open bracket n is n minus 1 by a common difference, in this case is 2, right? So you can leave it like this. I think you should always just break it down. Once you have brackets and you can multiply, break it down, okay? So AN, or your n term, is 5 plus 2 by n. Remember, we have to multiply the number outside by the bracket, whatever is in the bracket, each term in the bracket. So 2 by n is 2n, and minus 1 by 2 is minus 2. So this is it so far. So AN is equals to 5 minus 2 plus 2n. We group like terms. 5 minus 2 is 3 plus 2n, or if you put 2n plus 3, vice versa, same thing. So my formula for this would be 2n plus 3, and that would be your answer for this section. Now guys, the reason why I say usually to find part 3 out first, it is super easy to just put in when n is equals to 11. That's 2 by 11 plus 3. 2 by 11 plus 3 will give you 25. You see how much easier it is? But if you remember this formula and you could do it that way, you're supposed to get the same answer, right? Now this one here, we already talked about the first term, the second term, and the third term, right? We know that your first term in your total number of squares would be n, right? Then plus 2, which is 2 is a constant, all squared, and that would be, well, I'm not going to put what this is equal to. You'll just have to square it and stuff, but this would be your answer for this section here. Now, guys, this is the table. We're filling out the table. I don't know how come they didn't ask you for this. They probably did. I just totally forgot to put a line. Let's find out for this. This one is super easy as well. We know that my figure number is n, right? So we're going to do it for parameter of p, right? So my figure, just now, my figure number is n. A1 in parameter of the squares is actually 12. Parameter of the figure is 12, right? And my common difference in that section was, let's make sure, is it 4? I think it was 4. It is 4, right? So you put it in the formula, an is equals to a1. I'll write it over. An is equals to a1 plus n minus 1 by d. So an is equals to a1 is 12 plus open bracket n minus 1 by a common difference of 4. So this is an is equals to 12. You multiply the bracket by 4, so that would be plus 4n minus 4. You group like terms, so you have 4n plus 12 minus 4. 12 minus 4 is 8, so it's going to be 4n plus 8. And that would be your formula for the second part here. 4n plus 8. Right, as I said, guys, if you have these formulas for n, it is super easy to do the rest of the table. Right? Yeah. So this is how you would fill out this table. Now let's look at part C. It asks you how many white squares in figure 11. Now, guys, if we look at the pattern here, right, your white squares would obviously be all the squares minus how many shaded squares is equal to, right? And if we look at this, they told you the total number of squares and they told you the number of colored squares. So obviously your white squares, hold on, let me write this properly, right? So your white squares would be equal to a total number of squares minus the number of colored squares minus the number of colored squares. Right? So your white squares is equal to, so if they told you for figure 11, we already found that out. Figure 11 was 169, right? 169 minus the total number of colored squares was 25. Right, so 169 minus 25, 9 minus 5 is 4, 6 minus 2 is 4, so the number of white squares would be 144. And that would be your answer for, is this it? Yes, this would be your answer for number 7, the entire thing.